declarative programming is, of course, not only about XML. And he wanted so much for us to have a presentation on something else than XML, that when he couldn't reach the Mermaid programmers themselves, he said, okay, I'll present the Mermaid, a declarative diagramming tool. Take it away.
Thank you. So I'll start by telling a bit about diagrams in software engineering. Why would you use diagrams? Well, as it says here, a diagram is a symbolic representation, meaning it doesn't use normal language, words, sentences. It uses symbols, like mathematics, which represent information, and it presents those using a visualization technique. It's very general. What we use it for in software engineering is to give an overview of the structure of a complex system, and preferably one aspect, although there are many diagramming techniques and diagrams that I've seen that try to fit it all into one diagram, so then it becomes more than one aspect. And it helps us to understand how a complex system works. And as we'll see later, it can also help us to solve problems that occur with software. It also helps us to communicate. So diagrams are often more understandable for our clients and users than program code. And it allows them to provide feedback. We can even communicate with extraterrestrial civilizations, which has been tried this way. That's the plate on the Pioneer 10 and Pioneer 11 spacecraft. And they're somewhere out there hoping to meet some civilization in the universe someday. So what kind of diagrams do we have? Well, I've listed a few here, and there are lots more actually. So in 1921, there were flowcharts, and this is the original publication where that was introduced. And here's some of the definitions that they provided for flowcharts. So that's a real old technique, which is still very much in use. Then in the 70s, we had these Nassi-Shneiderman diagrams. This is the original publication from SIGPlan. And here's one representation of the computation of a factorial. So they have if, then, else's, they've got loops. It's actually a lot more elaborate than just writing the code. But some people thought this was a real good idea. Then we have entity relationship diagrams introduced by Chun, 1976. This is how it originally looked, which is a bit different from how we use this today. This is an overview of all the versions of UML and everything that led up to it. I haven't included UML diagrams, but this shows how complicated this has become. And to make this simpler, the C4 model was introduced in 2006, which only uses part of UML, the part that is most useful and that's most used. So there are other diagrams. There's control flow, data flow, workflow, syntax diagrams, lots of diagrams. So I need to say something about the use of diagrams, because in themselves they don't mean much. This is Edgar Dijkstra, who said a picture may be worth 1,000 words, but a formula is worth 1,000 pictures. And you see him here explaining the Fibonacci, the computation of Fibonacci numbers, and also proving mathematical properties of those Fibonacci numbers. He did his PhD at CWI. He also, when there was a presentation from someone who showed diagrams with boxes and arrows, Dijkstra used to ask, what would happen if I turn all the arrows around? And many presenters couldn't answer that. Some of the problems with diagrams are their complexity. I just said a moment ago, they're used to make things simpler and more understandable, but often people use them to make things look very complicated. Yeah, I'm also speaking about Archimate here, which is a diagramming standard between inverted commas that makes things horribly complicated. And often people try to squeeze in too much information, and you get something like that figure on the right. So you need to keep a focus on what you want to present, and it should have meaning, which this diagram obviously does not have at all. Then we have executable diagrams. So there's the Schler-Meller executable UML stuff. There's XTUML, and these are all attempts to make UML diagrams in some way executable. I've experimented with this years ago. It works a little bit, meaning that you can actually generate code for the classes in a class diagram from a diagram, but you could also just write out the classes yourself, and it would save you a lot of effort. So I think I've now told a lot about why you shouldn't use diagrams. Still, we're going to draw diagrams. This is a diagram in Apache NiFi. This is actually a pipeline that was used to import large amounts of content into a database, and it works pretty nicely. The problem is what you see is what you get with this diagram, meaning it can only execute this diagram, and it's very hard to make abstractions or what we would call functions or methods or subroutines. But it works. It can route your data through this graph, make decisions, have loops, and it's actually quite fast, and it can process huge amounts of data. Then we have other kinds of executable diagrams. This is taken from YAL, yet another workflow language, a business processing model. And it actually works quite nicely too. So it executes the diagrams. It uses XQuery for expressions, which I think is great. And users tend to understand this, especially for something like workflow. You have the users from the business side who want to specify that, and this works quite well. So then the second part, how am I doing? I need to look at my own clock over there. How can we draw diagrams declaratively? First, these are some tools for diagramming that were used in the past. These plastic templates, they appeared in the 1950s, I think. My father used to have one, and I like diagramming with it. You could all make all sorts of funny pictures with it. Then, of course, there are electronic tools. I've listed a few here. Again, Archimate. Okay. All these tools can be used to draw boxes and different kinds of lines between them, meaning you need to give a meaning to your boxes and lines, and you can position them anywhere on a canvas or a piece of paper. And then the question is, what does that mean? It's also a lot of work. I remember once at a big government office in the Netherlands, I was asked to redraw all their diagrams, which were made in Rational Rows version 5. They couldn't translate them to version 6, so I spent weeks porting all these diagrams. And at the end, I went to a lower floor, of course. I was a designer, and the lower floor had the developers sitting there. And I asked them, what do you actually do with these diagrams? And they said, oh, nothing. We just make whatever is needed. So declarative diagramming is a bit different. You don't draw the boxes and lines, which is the how things should be drawn. You specify it as code, which means you specify what needs to be done, not necessarily whether the boxes have a yellow background, whether the arrow needs to go left or right of another box, where things need to appear on the canvas. So I think that's really declarative instead of a more imperative way of drawing boxes and arrows. And in recent years, there have been many implementations of this. I've listed a few here and here. I will look at Mermaid, because it's just one that I happen to come across. There are a few links here. There's the mermaidjs.org, it's written in JavaScript. And there's the mermaid.live, where you can draw diagrams live. I'll show that in a moment. There are 2 books about Mermaid. You can also just look at the website. It has all the information you need. And there are several Visual Studio Code plugins, like the one over here, the Markdown Preview Mermaid support, which we'll also see in a moment. Good, so it's demo time. That's always a bit risky, but I think it doesn't work, yeah? Okay, so I need to draw this over to here, and then I'll have a real difficult time to see what I'm doing. So if I go over here, I can type something like, so this is an arrow from A to B, and I also want an arrow from A to C, which I've got now. And then I want all of those to end in D. Yeah, that looks sort of good. So you can save diagrams here. You can interactively make them, which I think is kind of fun. And here we have, oh, this is really going to be difficult. I lost my cursor. Okay. And this is sample flowchart. This is Visual Studio Code. You can see I'm making a flowchart. There's 2 ways of representing this diagram. And so you can make 4 arrows or have an abbreviated version like the one below, which I just made at mermaid.live. And here I have a link to what I just made on Mermaid Live. So I hope that still works, yeah? Actually, it's now from left to right. You can click on it and that will take you to the Mermaid Live website. This is more difficult than I thought. Oh, okay, maybe I won't show all the demos, but I've again lost my cursor. There we go. So I'll go to the second example. Scroll up. Sorry about that. And then I hadn't expected that I would have 2 screens.
Nico, if you want, you could reduce font size a bit, or
no, the problem is I've got
very
2
legible.
screens.
Okay.
So maybe if I do it like this, that should be better. So here I've tried to make a picture of the XPath axis. As you can see here, it's a lot of code, and especially since I've magnified it, but it gives quite a good picture, I think. Only I've used subdiagrams here. You can see that over here, a subgraph. And so you can nest things in yellow boxes in this case. I didn't specify that. That is what Mermaid did for me. But you can't have overlapping boxes. So I can't show the ancestor or self or descendant or self boxes because they overlap with the other boxes. That's a limitation. But usually for flowcharts, that wouldn't be a problem. So they could introduce a slightly different type of diagram in Mermaid, which would allow overlapping boxes. It's just not done yet. So here you have a bit of an idea how much code is in. It's actually not so much. So on to the next. So here I've tried to recreate a diagram that Stephen will show tomorrow. This is really big. It's this diagram, and it's about the IXML. What's the title of the lecture again? Oh, it's somewhere up there. Declarative code browser with IXML and XForms. And so here's my first attempt. which says it's a flowchart from left to right. I've got this description in a sort of triangular box. That's what these square brackets and slashes indicate. And it has an arrow to IXML proc. IXML proc is a circle with IXML processor in it. So I can give an identifier to that, which I can reuse somewhere else, like here. So this looks kind of okay, but the problem is that Mermaid, because it will do the layout for us, will try to do everything from left to right, and there's not yet a way to escape from that and say, no, this arrow has to go from top to bottom, but it will be possible in the future. That would be good. So I did some other things. You could use subgraphs like here, but when you link into the subgraph, like that arrow from description to XML processor, the same thing will happen. And here I try to link to that subgraph. I think this is the best we can currently do. It did save me a lot of time drawing that diagram, and I can easily change it, which I think is an advantage, even though it's not ideal. Or it's not exactly the same what Stephen did.
Can I get SVG out of it?
Yes. So there are several renderers, and you can choose different renderers. So here I've made class diagrams, well known from UML. So here I show how you make the different kinds of arrows. Basically, it looks similar to what you would draw or what the line looks like. And here I've got a class diagram, and I've magnified it quite a bit, which makes it actually less readable. But you can make quite elaborate diagrams with relatively little syntax. Maybe if I make this a bit smaller, I know I needed to make this pretty big, because otherwise it wouldn't be visible on Zoom. So apologies to the people on Zoom. They might not be able to see this. So here we have, okay, a sequence diagram. This is the registration process for Declarative Amsterdam. So here you see, get this out of the way. And there's the participants. There's an actor, that's the attendee, and two participants, which is the registration service and the payment service. And then the attendee sends a message to the registration service to register. It responds. This is the response arrow here with thank you. And then if you're not a presenter, there will be a payment link. Some of you may have noticed that. And so that we send a message to the payment service, make the payment link. It responds by sending the payment link back, which is emailed to you. And then at some time in the future, you choose to fulfill the payment, and it says thank you. And then Peter gets a notification that, or Eric, I think, that the payment has been fulfilled. You both get it, and then it's filled in the database, which I've not shown here. So now you know how that works. Here's an example entity relationship diagram. Just one of the examples. Yeah, I think these 5 lines of code are way easier and faster to type than actually drawing this diagram. And then when you have to change it, you have to move all the boxes around and it never fits. So this is quite good. Here I've got some other examples. Oh, this really doesn't work because I need to zoom out. It worked for me. So this is a Gantt chart, but I think, I don't know what happened. It doesn't look good here because it doesn't want to magnify itself. So that's a shame. It did look good. when it was on wasn't scaled up. Oh wait, okay. Here is a quadrant chart, and okay, there's some limitations of this visualization tool that I use. Maybe if I try to do this, no, that's not going to work. Pie charts are possible, and when you don't magnify them, they look good. What's this type of chart called again? I forgot. It's this, yeah, Sankey diagram. And mind maps are possible. So there's quite a few types. These are only a few of the possible diagrams. There's a long list, and it's growing, and they're expanding this. I think that was the last demo. So I'll try to go back here. Good. So what are the advantages of this? Well, I think you've seen a few of them. You specify what to draw, not how. We're not all graphical artists, especially when we're software developers. So it's better to leave the drawing to a tool that can do it in a way that's maybe not perfect, but it saves us a lot of time. Maintenance is, I think, an obvious advantage. You can easily change arrows, and the diagram will adapt accordingly. And you don't have to spend 10 minutes trying to figure out how to get the arrows straight and not slightly slanted, so they look terrible. It's interactive, like I showed earlier. You have real-time updates within a fraction of a second, and that's very helpful when you work on a project with a customer and you make decisions. You can visualize them immediately, so they can give you feedback immediately. Another advantage, which I will show next, is that it's much easier to generate these diagrams with code than when you have to generate like diagrams in rational rows. I know there's an XML version of those diagrams, which I've never understood, so it would be very hard for me to generate that. And you might even be able to execute diagrams. I'm today not going to give an example of that, but it's easy to see how you could parse this syntax using IXML, for instance, and then transform it into whatever programming language you like, and you can draw a program that way, but you don't really have to draw. You specify it in a different kind of code. So that's next, generating diagrams. And I've used this for code analysis. I've been working on a web component, a kind of combo select component. You can see an example over here. So it's a selection list, but you can type a prefix of what you're looking for, and it will filter the options. You can even enter free text. There are details that you can show. I've lost my cursor. Here's my cursor. So when you click on this, it will show some descriptive text about an option. There are some buttons at the bottom that you can customize. So it's quite a large component, and all web components respond to many events during their life cycle. This component has more than 40 functions in JavaScript. It's actually at the moment over 1,000 lines because Peter asked me to implement some additional features. And there's many paths that can be followed through the code, which is a problem. So after we had used this component for a while and I had added features like Peter asked me to do, it became very slow. And when I looked into that, I saw that some of the functions in there, they were called 2 or 3 times when a certain event happened. And some of these methods, for instance, they position the box with the options on the screen so that it doesn't fall off the screen. And sometimes it has to be shifted up. It needs to be resized. And when you do that 3 times, it is noticeably slower in the browser than when you do it 1 time. But looking at these 1,000 lines of code, yeah, I couldn't figure out where this happened. So I thought, what if I would make a call graph of all the functions in this web component so I can see where the arrows go. So that's indeed what I did. I think now I'll show you briefly the code of this web component when I click. Yeah, there it goes. That's it. Good. So here's an example of the code where a function is called too often. We have a method load filtered options. And then here line 573, it calls set filter options and show options list. But in show options list, line 616, it calls set filtered options again. And that calls other functions, and those functions call other functions. So this is one place where it became slow. Now, how would this look in a call graph? You can see that here there are paths from load filtered options. That was the first method in the previous slide, to set filtered options in the middle. But there is also an arrow via show options list. That's the bottom two arrows in yellow. And these are two parallel paths. And that represents a case where potentially a method or a function is called twice. In this case, it was called twice. So by looking at the arrows, even it's a bit of spaghetti, it made it a lot easier for me to figure out where functions were called too often. And I could identify a few of these cases and indeed make the component a lot faster. Then I revised the code, and this was the result. Here you see the green arrows, functionality stayed the same, but now you see there are no more parallel arrows anymore. So every function is called only once, except that some of you may already notice this arrow here at the bottom. Don't have a pointer with me, but it's shown in the next slide. There is still a parallel arrow. However, and this is one of the limitations of my first approach, as you can see there in the code, there's an if-else statement. So the upper arrow is called in the if case, and the lower red dotted arrow is called in the else branch. So actually, this does not represent a function that's called twice. They're just alternatives. This means that actually what I should have done is not to generate one call graph, but generate two call graphs for every if-else that's in the code. And then you get lots of call graphs, and you can look at them. They're much simpler than this one, so that's an advantage. But you have to look through all of them to identify parallel paths through the call graphs. By the way, the code to generate these graphs, I think that's on the next slide, yeah. It's specific for web components, how I made it. You can have a look at it. It's on GitHub. Why is it specific for web components? Because all the paths through this call graph start with a constructor of the web component or with an event that happens, which for a web component are the starting points of a sequence of function calls. So what do I still need to do? Well, it would be nice if we could highlight the parallel paths in the graph by just generating different arrows in Mermaid, maybe dotted arrows or thicker arrows, which is all possible. And then the code that analyzes the program needs to generate that. It would be nice to generalize it to other types of code, not just web components, but that should be relatively easy. And we need to split diagrams at if-else branches. Here's this future thing I briefly referred to, maybe to use IXML to parse Mermaid syntax and generate code from that. Or parse the diagram and then let the computer figure out where there are potential parallel code paths. That's a very good idea. How would we do that? We could use an algorithm. And I'm not referring here to what people nowadays refer to as algorithm, which is a model in some AI or machine learning program. Yeah, it's terrible, isn't it? this is an algorithm like how to compute something. So we could use the widest path problem, which you can solve with the Schulze method, Floyd-Warshall, or Dijkstra algorithm, where you just assign a weight to each arrow, each edge in the diagram, which would be 1 in our case, and then find the width, the parallel weight of path between 2 nodes in the diagram. It's not the most efficient algorithm you could imagine, but it would work. And I almost did it, but I didn't have time for that. Or, since this is the age of AI, we could use a large language model or a generative pre-trained transformer to do that for us, because we're lazy, aren't we? So AI or large language models have been described as the ultimate declarative programming language. You just tell them what kind of program you want, and out comes the JavaScript code or Java code. I tried it for XSLT and XQuery, and it got totally confused, but it made up some really interesting functions. And I think I saw one of those functions in Norm's presentation. Oh, yeah, that's a predictive part, exactly. Often it's just a hallucinating stochastic parrot. But maybe it's in between, and these large language models are just a glorified search engine. Actually, is how I use it mostly. It just saves me a lot of time generating what is boilerplate code, and it's much more efficient to search for it in ChatGPT than in Google or Ecosia, which you should use, not Google. So what I've used is an application of ChatGPT, find.com. Find, yeah, it's find.com. There's a small screenshot here. You can just describe your task in detail. What are you stuck on? It uses GPT-4, and you can put it in pair programmer mode, and then you can just program nicely together with the AI. So here's what I did. This is the diagram I made earlier. I've highlighted some of the arrows, and I was given the Mermaid diagram below. Find pairs of nodes from A to B that have more than one path from A to B. Okay, here's my Mermaid diagram. And this is what ChatGPT says. Basically, it lists every arrow in the diagram. That's not what I wanted. So the text is okay. We need to look for nodes that have more than one arrow leading from A to B. Well, actually, it's not really the case. So I was trying to, here it says, yeah, well, it knows Mermaid diagrams. It knows how arrows are represented. Therefore, any pair of nodes that have more than one arrow connecting them can be considered to have more than one path. And still, it gives me every arrow in the diagram. So I was trying to help it by saying, can you include paths that consist of more than one arrow? Because it only gave single arrows, not the transitive closure of the diagram. So I explained what a transitive closure is to find if there's an arrow from A to C, an arrow from C to B, then there's a path from A to B. So it answered again, and most of the answers here are wrong. There's one that's right. Okay. And again, it says here, you could use an algorithm like Floyd-Warshall, and it gives the right references to the algorithms, but it has no idea what it's telling me because it can't apply them. So, okay, here's one path from the constructor to set HTML content, just to prove that ChatGPT is wrong. And it says here, the second line, there's more than one path between constructor and set HTML content, which is clearly not true. And here's the diagram for that. So, can we generate diagrams? So this is nice, but I thought, okay, I'll figure it out myself. Then I tried to generate diagrams from descriptions. There's an article online, which I thought, yeah, that's nice. I should try that. So I gave ChatGPT or Find a task to generate a diagram for a content aggregation system, which consists of these components. Well, basically there's connectors to external sources. You can extract and transform content from those external sources, import it into a database using a loader. So it's a description of ETL, basically. And then there's a search index that creates search index in this engine so that you can query it. Yeah, then create a C4 context diagram using Mermaid syntax. This is what it came up with. Yeah, it doesn't add a lot, I'm afraid. The external sources are now part of the content aggregation system, although they're external. The user is external, it's good. The user is not absorbed by the system. And they can do a search query and get search results. Nothing earth-shattering here. So I thought, okay, maybe it's not a very common thing to generate a diagram for a content aggregation system. Maybe I should ask for something that's more common, like how can a user interact with a web app and log in using OAuth 2? That's something that's all over the internet, so surely ChatGPT should know how that works. So I asked this, please generate a sequence diagram in Mermaid syntax to explain how that works. And the result looks convincing, but it's slightly wrong. So if you want to use this to understand OAuth 2, yes? Yeah, yes, yeah, yes. So it's convincing. One of the reasons why this may have gone wrong, whereas in the article I referred to earlier on the previous slide, let me see if I can get that back. Here they asked the same question, but they said, generate a diagram in plant.uml. And plant.uml is a declarative syntax to draw UML diagrams, but it's more common than Mermaid. And it worked better for them, probably because there are more plant.uml diagrams online than Mermaid diagrams. Oh, wrong button. So the conclusion, I think that using a declarative syntax for diagrams can save a lot of time and effort. And I've used it for several projects and it works well. There are plugins for Mermaid for things like Confluence. So you can use it in Confluence if you happen to use that for other wikis. It integrates very nicely with Markdown syntax. Fine-tuning the layout is not possible, but in many cases, I think that's not what you should want. You can spend hours fine-tuning the layout of your diagram, only to find that when you change the diagram, you have to do it all over again. Generating diagrams from code can provide some insights in your code. It was really helpful for me to speed up this web component. But a real code analyzer might be more useful. So if the analyzer, and I'm planning to do this in the future with my code, if it could just say, there's definitely a parallel path here, taking into account all the if-then else's, that would be a bit more useful. And a conclusion is that AI is not going to take our jobs, probably, because we do complicated stuff. We're the old people doing XML, XQuery, but the JSON generation, they should be worried maybe. Thank you. It says 10 seconds left. Great. Are there any questions behind you, Peter?
Hello, thanks, Nico. That was really interesting. I think declarative syntax is fantastic.
Yes.
But I have a question about lock-in. So yeah, sort of vendor lock-in. So over the years, I've used maybe 5 different diagramming packages. Every single one of them is incompatible with the next. And I've got diagrams in all of these things that I've accumulated. So my recent attempts, I've been using Lucid Chart, which is one of the ones you mentioned. and they now have a declarative approach. And I have quite a large sequence diagram in Lucidchart. And I just copied and pasted the syntax into Mermaid Live, and it doesn't work. So
Yeah.
is there any sort of standardization for these declarative syntaxes?
Ooh, so the question is, I don't know if it was audible on Zoom, is there any standardization, or are you locked into a specific syntax? And I'm afraid at the moment there is a syntax lock-in. But if you want to translate from one syntax to another, and if they support the same features for the diagram you're trying to convert, my approach would be to get IXML, keep advertising this, parse it, have some abstract syntax about the diagram you want to translate, and then translate it into the other syntax, which probably is a lot better than the situation I found myself in years ago, where I had to convert from rational rows version 5 to 6, which was a nightmare. But yeah, there's this risk. There's, as far as I know, no standardization. And yeah, probably there should be, because there's not so much difference. It's really in details where there are differences. And Mermaid does accept plant UML syntax now, but not Lucidchart, unfortunately. No. So we have to do this ourselves. It's interesting. 30 years ago, I wrote my PhD thesis about exactly this problem, and it's still a problem.
Yeah, thank you for your nice talk. And one thing that you did not mention, which I really like about those charts, is that when you have them in a Git repository, then you see what changes over time.
Yes.
One thing you can't with images without external tools that do that.
Yes. Yeah, true. So indeed, you can see changes immediately, which is a big advantage. Yeah. And it's an advantage actually of all declarative formalisms, that you can easily make changes. You don't have to spend an hour programming, and you can almost instantly see the result of that. And I think that's one of the things we should advertise more as one of the advantages of declarative approaches. Stephen has a question.
Matt, you can't go yet because there are still announcements to come. Stephen.
Thank you. So you used a diagram from my talk tomorrow,
Yes.
and it won't. Well, so it's SVG at its base, but SVG I find a little irritating because it's only partly declarative.
Yes.
That you still have to do lots of how in it. So that diagram, it will not surprise you to learn, I made with an Xforms application. And a specific language for doing that sort of diagram, where I could define my own primitives. Because when you've got a diagram, there are relationships that are always the same, and if you move something, then that means that other things have to move as well. So Xforms helped there, and I then thought, well, maybe I should turn this into a paper for a future conference. Yes. On declarative diagramming. Where you're using constraints to keep things the same, and yeah. Maybe we can work on it together.
That would be very interesting indeed. I was wondering if you had used a tool for that, or if you really made it in SVG. Of course, you made a tool, and it's declarative. Yeah.
I have a question for David Warren. David, have you been diagramming Prolog?
Aha.
Would you be interested in doing the Mermaid?
I'm David Warren from Stony Brook University in New York, and I do Prolog. My question here, I mean, I'm not convinced of the use of coding through diagrams. Evidence is it's easier to write the code than it is to write the diagram, right? So now understandability can be helped.
Yes.
But creation, I'm not convinced can be helped, because it seems to me the diagram has more extraneous information in it than you need to give, and again, I give evidence that you don't want to draw the diagram. You want to write the code that specifies the diagram. Well, if what you want to get to is what the code does, why have, what's the diagram good for? It's maybe good for, and not just may, I think it can be good for understanding the code, but for creating the code, I don't see it as helpful. I could be wrong, but at least that's my takeaway. I mean, my experience in the past and my takeaway from I don't want to draw the diagram. I want to write the simple code and have the system generate the diagram for me. Is that fair?
Yeah, I can understand that. I think there's one case where drawing the diagram and translate that into code would be helpful, which are these workflow diagrams that I show, because users usually want not only to create those diagrams, those workflows, but they want to maintain them long after I've gone as a software developer. And many people are scared of code. It's strange, but it's yes, it's for understandability. Yeah.
And by all means, I mean, understandability of code is incredibly important. It's probably more important than creation of code because it lasts so much longer.
Yes.
Any code that's going to last very long is going to have other people look at it and they're going to have to understand it. So I don't mean to minimize the understandability aspect of it. But again, I think my experience is that, and my claim still would be that it's the understandability that it's useful for. It's not the creation that's useful for. It's actually more work, as you're putting out. It's more work to create the visual form, which is my experience is that, and my claim still would be that it's the understandability that it's useful for. It's not the creation that's useful for. It's actually more work, as you're putting out. It's more work to create the visual form, which is it helps with the understandability.
Yes, I think you're absolutely right, and which is why, unless I have to for a client, I don't create code using diagrams. I don't start creating the diagrams. I became interested again in diagrams when I needed to analyze this web component, and then I thought, yeah, now I want to have a visualization, but all the UML diagrams and this whole RUP approach or Archimate, it's just a waste of time.
I think that's a great conclusion.
It's 5 o'clock.
Well, thank you very much, Nico.